This video is an introduction and motivation to Section 1.5 Factoring Polynomials. We use polynomials to represent many real-life scenarios, and factoring polynomials is an important technique for working with them. There are many techniques for factoring polynomials, and we'll talk about some of them in this video. To start off, let's talk about the greatest common factor of a polynomial, or GCF. Recall that the GCF of two numbers is the largest number that divides evenly into both numbers. An example of this would be the GCF, or greatest common factor, of 18 and 24 is 6. Then we have a notion of the GCF of two polynomials. And it's just what you'd expect. It's the largest polynomial that divides evenly into both polynomials. So as an example, building off the last one, the GCF of 18x squared and 24x is 6x. So we take the greatest common factor of the coefficients and the greatest common factor of the variable term and combine it to get 6x. Using the GCF comes up a lot when factoring polynomials. And an important example of this is when factoring polynomials or factoring expressions with either fractional or negative exponents. In that case, we use the technique of factoring out the greatest common factor of the expression. Let's talk about another technique of factoring by grouping. So let's say we have a trinomial of the form ax squared plus bx plus c, and we want to factor this. The trick is to find two numbers. Let's call them P and Q. such that P plus Q equals B and P times Q is equal to A times C from our polynomial. Once we find these numbers, P and Q, we can rewrite the polynomial splitting up the middle term using P and Q instead of B. So we would get AX squared plus PX plus QX plus C. Once we have this, we factor the greatest common factor out of the first two terms. We factor out the GCF. We do the same with the second two terms. Factor out the GCF. And then we rewrite that again. And then the whole thing, once we have it rewritten, we then again factor out the GCF of the whole thing. You can see a couple examples of this in the section that you'll read on perusal. Finally, let's talk about some formulas for factoring. There are some special cases that come up, and it doesn't require much thought beyond recognizing that you're in this special case. Once you know that, you can follow these formulas to factor. The first one is when we're in the case of a perfect square trinomial. So this will come up if you have something of the form a squared plus 2ab plus b squared. And the formula to factor this is just the binomial a plus b squared. Again, this is called a perfect square trinomial because we can factor it as the square of a binomial. Okay, the next formula that we have is in the case of a difference of perfect squares. So this is when we have something of the form a squared minus b squared. And we can factor this as a plus b times a minus b. Again, this is called the difference of squares formula. Okay, the next two are working with cubes. First, we have the sum of cubes. So we have a cubed plus b cubed. And the formula for factoring this is a plus b times a squared minus ab plus b squared. Then we're in the case of sum of cubes. Lastly, we have the difference of cubes, a cubed minus b cubed. And we can factor this in the form a minus b all times a squared plus ab plus b squared. And again, this is when we're working with a difference of cubes. So these formulas come in handy when we can recognize that we're in one of these special cases. Just a reminder, remember that you have a reading on perusal to learn more about factoring and to look at some examples. If you have any questions, please bring them to class.